The last few classes, our main focus has been on probability. Probability is, well, typically we look at it as the percent chance or the likelihood that something is going to happen. So if I flip a coin, 50% chance that it's going to land heads. We've been looking at different probabilities. Today we're going to start looking at odds and expectations. Today we're going to focus on odds. Next class we'll look at expectations. The odds, if we're comparing it to probability, they do describe the likelihood of something happening, so similar to probability. So if you've ever heard the phrase, the odds of something happening, so the odds of getting struck by lightning, the odds of winning the lottery, that's what we're looking at today. Odds are typically used by casinos, racetracks, other gambling establishments to determine the payoffs when bets are made or when lottery tickets are purchased. So your actual odds of winning. And it's also used by insurance companies when they determine the amount they're going to charge for premiums. So when they decide for your insurance what the rate will be, they're figuring the odds of you getting in an accident or the odds of somebody getting badly hurt because the car you drive has airbags or doesn't have airbags. So just different types of things that they look at. Given your age, they look at the odds that you will be distracted while driving. All those different types of things. When we write odds, however, those are typically expressed as a fraction or a ratio. With probabilities, oftentimes probabilities, we hear them as a percent. There's a 30% chance of rain today. But the odds of my winning the lottery are 1 in 500 million or something like that. I don't know what it is exactly. The phrase the odds of, so the odds of my winning the lottery, actually really means it's the odds against me winning it. And as we go through how we actually figure out the odds in favor and the odds of against something happening, that'll be a little more clear what that means. All right, so let's take a look at how we actually figure out the odds. If an event E, and that capital E, we've been using that for our events since we started doing the probability. The event could be tossing a coin. The event could be rolling a die. The event could be selecting a student from class. Lots of different things. Event is a very, very broad term. If it has A, favorable outcomes, not a favorable outcome, it's a variable A, and B, unfavorable outcomes. So a favorable outcome means that that event does happen. So a favorable outcome means that that event does happen. And the unfavorable outcome would mean the event does not happen. So favorable versus unfavorable. The event happens versus the event doesn't happen. If we combine the favorable outcomes and the unfavorable outcomes, it gives us our total. Then the odds in favor of an event happening, and I put it in words and I just use the variables. The odds in favor of an event actually occurring is the number of favorable outcomes over the number of unfavorable outcomes. And then the odds against something happening, number of unfavorable versus the number of favorable. Give you guys a minute to write that down, and then we're going to talk about how this is different from the probability we've been doing. So let's just compare what finding odds means compared to the probabilities we've been finding. What's the big difference between the probabilities we've been finding and now finding the odds. What do you guys notice is the big difference? When we looked at probabilities, our numerator, we were always concerned with our number of favorable outcomes. So how often does that event actually occur? But when we did probability, what was our denominator always? What has our denominator always been? We've been working on it now for the last 3 sections. What did you always put in the denominator? Was it just how many times the event doesn't happen? Or was it the total number of possibilities? What do you think? It was always our total number of possibilities. So let's just throw an example out there. We have Senior Survivor this week. How many total survivors were there to start? Anybody know? How many total started? A couple of you in here were in it. How many of you guys started? 12? Okay, so we had 12 that started. 12 that started. If we're trying to figure out the winner, what's the percent chance that what's the probability that one person wins? What's the probability? So what's the probability that Caitlin was in Senior Survivor? What's the probability Caitlin wins? How many Caitlins are there? There's one Caitlin. How many total tributes? How many total tributes were there? 12. So the probability that Caitlin wins Senior Survivor, 1/12. The odds that she wins it, so this is probability, 1/12, or we could change it to a percent. So the probability 1/12, or that is 8 1/3%. So the probability that a person wins Senior Survivor is 8 1/3%. It's probability. Now the odds that somebody wins, there's that one winner, so my number of favorable outcomes is 1. So odds in favor would be 1 for the number of favorable outcomes. One person wins. But then, how many unfavorable outcomes are there? So how many non-winners are there? There's 11. So the probability that somebody wins Senior Survivor is 8 1/3%, or 1/12. The odds that they win it are 1 to 11. So the odds that they win it are 1 to 11. So the big difference between probability and odds, probability, we want all the possible total number of outcomes for our denominator. For odds, I want how many favorable versus unfavorable. Not favorable versus the total, favorable versus unfavorable. That's the biggest difference between the two. So let's take a look at a few more, just finding the odds. We're going to draw a card from a deck. Find the odds in favor that we get a queen. Find the odds in favor that we get a queen. So if we want to break this down, if you guys like labeling, some people like labeling the variables. They get, Miss Golly, there was an A and a B in that formula, so let's pick out an A and a B. We can do that. A represents the number of favorable outcomes that we have. So in this case, a queen is our favorable outcome. That's the event that we want to have happen. We want to draw a queen. That's our favorable outcome. So how many queens are in our deck? 4. So there's 4 queens in a deck. But now that B, I don't want the total number of cards. I want the total number of cards that are not what? that are not queens. So how many are not queens? 48. So there's 48 that are not queens. That's the biggest difference between the two. Otherwise, odds and probability, they're very similar. They're very similar. So how we can write this answer, you can write it two different ways. So the odds in favor of getting a queen, you could put 4 over 48, which just simplifies to 1 in 12. Oftentimes, though, when you guys see or hear odds, they're written as a ratio using the colon. So the odds that we reach into a deck and draw out a queen are 1 to 12. So we're not seeing it as 1/12, even though it's written as a fraction that way. We need to look at it more as a ratio, that the odds that we reach into the deck and draw out a queen are 1 to 12. We're not looking at it as 1/12 or it came out to be 8 1/3%. We're not looking for that probability. We're looking for the odds. So the odds that we reach into a deck and draw out a queen are 1 to 12. You can write it either way. I'm fine with that. You can write it either way. The other way we can do this, we also can do the odds against something happening. So the odds against getting an ace. No matter if you're finding odds in favor or odds against, you still want to find your number of favorable and unfavorable outcomes. So how many ways could that event happen? How many ways could that event not happen? Your favorable outcome, even though it says odds against getting an ace, this is the part that can get a little fuzzy for people. Even though it says odds against getting an ace is still my favorable outcome. Getting that ace is still my favorable outcome. I know we're looking for odds against it, but it's still my favorable outcome. So my A is still 4 because there's 4 aces. Then my B is still my unfavorables. So how many cards are not aces? So 48 cards are not aces. So then now if you want the odds against this happening, we just flip-flop it. So the odds against are the number of unfavorable versus the number of favorable outcomes. So you just flip-flop it. Odds in favor, odds against, you just flip-flop. Now I realize, and here's one thing we have to be careful of. I realize that 48 divided by 4 is 12. But when you're expressing odds in favor, odds against, it doesn't matter. We need a ratio. So we need a fraction, or we need to write it with the colon, because we need to make that comparison. Favorable versus unfavorable, unfavorable versus favorable, whatever you happen to be comparing. So I need to be able to read this as the odds against getting an ace are 12 to 1. The odds against getting an ace are 12 to 1. So I can't just put a 12. Odds against getting an ace are 12. 12 compared to what? So just be very careful if you come across one that would simplify to a whole number. We still need the fraction or we need the colon. We need the 1 in there. We need the 1. Example 2, what are the odds in favor of rolling a prime number sum with a roll of 2 dice? What are the odds against? That sample space of rolling 2 dice, I know we made that in our notes. It can also be found on page 601 in your book. Page 601 has that sample space for rolling 2 dice. So you guys have this question on your sheet. I'll put that sample space up underneath the Elmo. And we want to find the odds in favor of rolling a prime number sum with a roll of 2 dice. So I'm going to put these up and you guys figure out how many prime number sums there are. So what's our A? We want prime number sums. That's our favorable outcome. And we'll talk about the B. Whoops. Alright, so looking at our sample space, we came up with that there are 15 prime number sums. Now, if you guys are ever asked to find a probability or the odds, and it's dealing with, for example, a prime number sum, and you don't know what a prime number is, please ask that question. I'm not ever going to test or assess you on, not in this particular unit, whether or not you know what a prime number is. I'm assessing to see, can you find the odds? Can you find the odds or the probability like we've been doing? So make sure you ask if you're not sure what some of those terms mean. So if we have 15 prime number sums, how many sums do I have that are not prime number sums? There are 36 total outcomes. There were 36 total pairings in our sample space, minus the 15 that are prime sums. So there'd be 21 non-prime number sums. So again, the odds are a little bit different look simply because we're not looking for the total number of outcomes. We're looking for the favorable versus unfavorable. So how many ways could it happen versus how many ways it can't happen? That's what we're looking for. So I know it's a little bit different way of thinking because we've been looking for how many ways can it happen over the total number of ways. That's our probability. Now with odds, how many ways can it happen versus how many ways can't it happen? So the odds in favor we have 15 prime number sums compared to 21 that are not. So 5 to 7, or you can write it also with the colon. Remember, with odds, we never want to write odds as a decimal or a percent. Odds are comparing the two totals for the outcomes. How many unfavorable versus favorable, or favorable versus unfavorable. We're making a comparison. That's why we say odds are expressed as a ratio. A ratio compares two numbers. A ratio compares two numbers. So if we write it as a decimal or percent, we can't make that comparison. So then the odds against us rolling that prime number sum is just going to be the exact opposite. There's 21 that are not a prime sum. There's 15 that are. So if you're looking at the same event, so our event is rolling a prime number sum. If you're looking at the same event, the odds in favor and the odds against will always be reciprocals of each other if you're looking at the same event. If you're looking at the same event, they'll always be reciprocals of each other. So now we've been talking about how the odds and probability are different. So let's take a look at, if I happen to know the probability of something happening, could I find the odds in favor or the odds against? In order to do that, we have a couple little formulas that we can use. And again, this is if we know the probabilities. Notice our P of E. Remember, that's the probability. The event, whatever it is, will happen. And then when we have the little bar over the E, That's the probability the event will not happen. So again, what we're looking at is if we know the probability of an event happening or the probability that it doesn't happen, we can find the odds in favor. Or if we're looking at from when we start off this section, we talked about it's used by a lot of racetracks, casinos, gambling institutions, whatever the case may be. So odds in favor, we can translate that into the odds of winning. Odds against would be your odds that you're going to lose. So if we know certain probabilities, can we then turn that into my odds of winning? For some people, that's easier to interpret versus, okay, here's my percent chance of winning. Well, what are the odds that I win? Because the odds makes the comparison between favorable outcomes versus unfavorable. So how many chances do I have of winning versus how many chances that I don't win? So let's try this out. The probability of getting 3 of a kind in 5-card poker is 0.0226. Find the odds in favor of getting 3 of a kind and the odds against getting 3 of a kind. So now I know the probability, but if I look at the probability, 0.0226, that doesn't tell me much about, well, how many times could I get a 3 of a kind versus how many times won't I get 3 of a kind. That's what the odds will show us, the actual number. It shows you the actual number. How many times could I win versus how many times won't I win. So let's use our little formula. Let's start off with the odds in favor. Odds in favor, and then we'll do odds against. So the odds in favor, if we look at our little formula, the numerator says the probability of our event happening. So the event is getting 3 of a kind. So probability 3 of a kind. So probability of the event happening, and the event in this case is getting 3 of a kind in poker. And then our denominator says 1 minus the probability of that event. So if we think back to our probability, what this is doing is this is comparing the probability that I get 3 of a kind versus the probability that I don't get 3 of a kind. Remember, 1 minus the probability of something happening is the same as the probability it doesn't happen. So the other way we can write that denominator is the probability that we don't get 3 of a kind. Remember, when we draw that bar over for our event, we draw that bar over our event, it means the probability it doesn't happen, which is the same thing as 1 minus the probability it does. So the probability it happens versus the probability it doesn't happen. Favorable outcomes versus unfavorable outcomes. Probability it happens versus probability it doesn't happen. So the probability that it happens, we're told, is 0.0226. So then the probability it doesn't happen is 1 minus 0.0226. I know you're thinking, well, Miss Galley, but you said people like odds better because they can see the number of favorable outcomes versus the number of unfavorable. So the number of times that we're going to get 3 of a kind versus the number of times we won't. How do those decimals help me? Well, you're right. Those decimals, they don't help us very much. So my odds in favor are 0.0226 to 0.9774. That doesn't help me much. So we have to go back to some of our knowledge about fractions, and we have to remember I can't have a decimal as part of a fraction. So any suggestions how I can fix that so I can actually see the number of times I'll get 3 of a kind versus the number of times I won't if I'm playing poker? What could I do besides put in my calculator and have it give me a fraction? And it might not change it for you. What can I do? Well, if it's been a while since we worked with fractions, we can, if I move my decimal 1, 2, 3, 4 times in the numerator, so I no longer have a decimal, I'll get 226. If I move my decimal 4 times in the numerator, I have to move it 4 in the denominator. And it can simplify. They're both even numbers, so I know I can at least divide by 2. And again, you can also write it with the colon. So the odds that I'm going to get a 3 of a kind when I'm playing poker are 113 to 4,887. So for some people, they like being able to see that split when they're trying to decide, am I going to win or not? So 113 times I'm going to win versus 4,887 times that I'm not going to win. I'm not going to get that 3 of a kind. Now the nice thing is then the odds against, if we're looking at the exact same event, remember odds in favor and the odds against, they're just reciprocals of each other. So if you found the odds in favor already and you want to find the odds against for the exact same event, getting 3 of a kind, they're just reciprocals. They're just reciprocals of each other. So 4,887 compared to 113. Or again, you can write it with a colon. That's oftentimes how you see odds written. Remember, you don't want to write odds as a decimal or a percent. Odds are actually showing you that comparison between how many times it could happen versus how many times it won't happen. Or how many times it won't happen versus how many times it will. You need that actual comparison for the odds. I want you guys to go ahead and see what you would set up for number 4. We're given the probability. According to the American Cancer Society, the probability of an American female developing cancer is about 1/3. Find the odds in favor of and against an American female developing cancer. So odds in favor. And I know the phrase odds in favor, it's not the best way of phrasing it for this, but basically odds in favor means the odds it will happen. The odds it will happen. So you're given the probability of 1/3, so see if you can put that probability in the right place. See what you come up with for this one. So our only difference from example 3 to example 4 is the probability that we're given is in fraction form instead of decimal. So if I want the odds that this event would happen, I want the probability that, unfortunately, somebody gets cancer versus the probability that they won't. Now, for some of us, the difficulty is going to be just working with a fraction and a fraction, or how we had decimals as part of our fraction, just remembering some of those rules for how we have to simplify those fractions. So the probability that somebody does, unfortunately, get cancer is 1/3. then the probability that they don't would be 1 minus that 1/3. Now I know some of you are thinking, Miss Golly, if I just know that's 2/3, can I just write that? Yeah, that's fine. I'm just showing you how I'm coming up with that. It's 1 minus the probability it will happen. So now I have to think about, I've got a fraction. How do I simplify that? I can't leave a fraction the same way I can't leave decimals in a fraction. If I try to change these to decimal form, I know some of you are thinking, oh, I'll just change it to a decimal, and I'll move the decimal points like we did in the first one, because I thought that was pretty easy. Unfortunately, if you change these two to decimals, they're both repeating decimals. So it's not going to help me to try to move a decimal point. You'll be moving it forever and ever and ever. It won't work. So let's go back to what the fraction bar means. What operation does that fraction bar mean? Yeah, means we divide. So 1/3 divided by 2/3. So again, here's where we have to think back to, how do I divide fractions? So a lot of this stuff, it's going to come down to remembering some of our basics that maybe we haven't worked with in a while. When I go to divide fractions, I leave the first one the same. Division becomes multiplication. And I flip the second one. That's usually the cause for confusion. Most people, if I ask them how to divide fractions, they said division becomes multiplication, but then the debate is always, well, which one do I flip? Do I flip them both? First one, second one? Flip the second one. Then when you multiply your fractions, we go straight across the top, straight across the bottom. So we'd have 1/2 or 1/2. Now here's where you have to be careful. Here's where you have to be very careful when comparing these two. The probability of American female developing cancer is about 1/3, or 33.33%, however you want to look at that. Now the odds, you're thinking, Miss Golly, how does it go from 1/3 and now it's a half? But it's not half. What this means is, for every one person that would get cancer, 2 do not. So it's not I have a 50% chance of getting it. It doesn't change from 1/3 to a half. Those are not the same numbers. 1/3 is the probability. 1/3 is the probability. So that's where we compare how many people will get it versus the total number of females. When you're looking at the odds, the 1 represents the 1 person that will compared to the 2 people that won't. The 1 person that will compared to the 2 people that won't. So going from probability to odds, there's where the difference is. Remember, probability compares, for example, how many people will get it compared to the total number of people. This is how many people will get it compared to the number of people that won't. So how many will versus how many won't. Instead of the probability, it's how many will versus the total. That's where you have to be careful with these. So now if we're given the probability, we can find the odds. The last thing I want to finish up with today is, if we're given the odds, can we find the probability? So the last one, we were given probability and we found the odds. Now if we're given odds, can we find the probability? So if we want to find the probability, if we know the odds in favor of an event, we can easily find the probability that that event will happen. And then this is the only thing that we need to worry about. If we want to find the probability something won't happen, we just do 1 minus this. If we're given the odds against something, the odds in favor, we know we just flip-flop. So instead of giving you a ton of different formulas to look at, we can just use this one and just reinterpret as we need. I'd rather go that route than give you a specific formula for each one. That'd be like 4 different formulas. Let's just use this one and readjust as we need. I think it's going to be our easier route. Remember at the very beginning of today when we first started talking about odds, we said that A was the number of favorable outcomes. We said B was the number of unfavorable. So A was the number of times our event will happen versus B, which is the number of times our event won't happen. But then we also said that if we add together A and B, we get our total number of outcomes. When we do probability, we want the number of times something will happen versus the total. So the number of times something will happen versus this would be the total number of outcomes. So how many times will it happen versus the total? Remember, the odds are how many times it will happen versus how many times it won't. Probability is how many times it will happen versus the total number of outcomes. So the total number of possibilities of if it can happen or not happen. So let's just finish up today, starting with some odds and getting some probabilities and seeing how we can adjust this particular formula as needed. Let's start off with example 5. Let's start off with one that's pretty straightforward. We don't have to adjust our formula at all. The odds that an event will occur, so the odds in favor, are 4 to 7. Find the probability that the event will occur. If you need to, I know some of you really like labeling the variables, linking it right back to that formula. If you want to do that, since it's odds in favor, odds that it will happen, the A comes first in the odds, B is listed second. So if you like labeling those things, that's fine. We can pop it right back to the formula. So the probability that the event will happen, and we don't have a specific event, so we're just going to call it B. I wanted to go as general as I could for this first one. We want our numerator, the total number of times that event will happen, and that's our A. How many times it will happen versus, now I need my total number of outcomes. My total number of outcomes, A plus B. So the odds that this event, whatever it happens to be, will occur are 4 to 7. So 4 times it will occur versus 7 times it won't. The probability, though, is 4/11. How many times it will occur versus the total number. So how many times it will occur versus the total number, whether it occurs or doesn't occur. Now with number 6, it says find the probability of an event when the odds against are 3 to 7. Now I realize you look back at the formula in the upper right hand corner of your sheet and you said, well, Miss Golly, it says if the odds in favor of. This says odds against, so how do we adjust that? The odds in favor of an event are your A versus B. Favorable outcomes versus unfavorable. Odds against are unfavorable versus favorable. This is why I don't want to give you a totally new formula, because we can pick out our A and B still, whether it's odds in favor or odds against. We can still pick out A and B. They're just flip-flopped. Odds in favor are A to B, like example 5. Odds against, we're comparing B to A. So now if I want that probability, my A in this case is 7. And then my total, I add together the A and B. I want to give you guys a chance to play around with number 7. This is the last one we're going to do today. See what you think. The odds in favor of getting a sum of 9 are 1 to 8. Find the probability of not getting a sum of 9 when 2 dice are rolled. See what you think with that one. So when 2 dice are rolled, the odds in favor, and that's the part you have to be careful on these so you can identify the number of favorable outcomes and unfavorable outcomes correctly. So odds in favor means my number of favorable outcomes comes first, unfavorable is second. And really, Miss Guy, do I have to do that A and B thing? Do I have to label those? No. I'm just trying to help you link it back to the formula. I know for some of you that helps you piece it together easier. Find the probability of not getting a sum of 9 when 2 dice are rolled. And I told you guys that one formula that we did, the probability of an event equals A divided by the quantity A plus B. So it's the only one we need. And that's true. So the probability of actually getting a sum of 9 would be my favorable outcome, which is 1, versus my unfavorable and favorable added together. So the probability that I get a sum of 9 is 1/9. So then we use our prior knowledge of probability to figure out what it will be to not get a sum of 9. So probability to not get a sum of 9, we just do 1 minus 1/9. So just that one little formula will work for us, no matter if we're given odds in favor, odds against, whether we're trying to find the probability the event will happen or the probability it won't. You can use the same little formula. We just have to make some small adjustments here and there. That's what I would stick with. We will worry about expectation next class. Your assignment is on the second sheet of your handout, but today you can only do 7 to 14 all today. You can only do 7 to 14 all today.